Okay, welcome to lecture 6.3. Okay, now here's another brain teaser for you. Um, suppose you go to Keith Poole's website, or suppose this is in the old days. I'm going to talk about the different, I'll call them flavors of nominate. There's W nominate, D nominate, DW nominate, um, Keith Poole. So it's Poole and Rosenthal who did it. Now there's another version where only Poole did it, and those are called Poole common space scores. That's kind of a different flavor of nominate. But suppose we're back in the old days when it was just plain vanilla nominate. Okay, and that's so far that's all I've talked about is the plain vanilla nominate. I've shown you the likelihood function. I talked about the data they used to estimate that. Suppose in the old days, you were told that, and by the way, so um, nominate. So remember, we had that omega squared that was multiplied by the dij y or n squared. That you find the right value of omega. Sometimes they call it W. That's where they get W nominate. Where really they called it omega. They look, omega looks like a W. Um, it was they used the Greek letter omega in their original article. But if you pick at the right value, it can force all the and find the right seed values and stop at the right time so you don't the ideal points don't drift too much. You can force it so that all the ideal points are in between -1 and 1. Okay. Suppose we're in the one-dimensional case. So, and same thing for two-dimensional case, you might want to make it, the vertical axis, make all the scores between -1 and 1. But for the moment, let's stay on the first-dimensional case. And by the way, they also put in some seed values that make it so that the smaller scores are negative legislators. The smaller scores are liberal legislators. Bigger scores are conservative legislators. By the way, so that's what first dimension nominate is. Now, there's and read my description of it that I wrote in my book Left Turn. There's nothing about nominate that forces the first dimension to be a left-right dimension or a liberal-conservative dimension. What the first dimension is it estimates we should interpret it as the conflict, the maximal area of conflict in Congress. Okay, the dimension of conflict that best predicts roll call votes. Now, it happens to be a left-right dimension, liberals versus conservatives. But you could imagine a world where it's something else. It's east versus west, what your district that you're from, or libertarian versus anti-libertarian. You could imagine that coming out being the dimension of conflict. So Poole and Rosenthal, they don't even read the text of the bills. So there's nothing that forces that nominate score to make it be a liberal conservative dimension. It's just that this is what pops out, that they see the ideal points of all these legislators, their estimates of their first dimensional scores. And Poole and Rosenthal, when they first did it, said, oh, wow, look, Ted Kennedy has a low score and Strom Thurmond, Jesse Helms have a very high score. This looks like it's measuring ideology, liberal/conservative ideology. And that's why they say, oh, the first dimension must be a liberal conservative dimension. Okay. So there's nothing that forces it to be that way. It's just in practice. The empirical results show that's what happens. Okay. So, what, gosh, I'm forgetting where I'm for the brain teaser. Okay. So, whatever the case, Poole and Rosenthal nominate scores. Low scores tend to be liberal legislators. High scores tend to be conservative legislators. Suppose that you did this. You estimated ideal points, and Chuck Schumer comes out with a negative zero point 0.5, and let's make it. I'm gonna make it negative zero point 0.8. Let's say, and Andrea Ocasio-Cortez (AOC) comes out with a negative zero point 0.6. Okay, so natural conclusion is to say, oh, Chuck Schumer is more liberal than AOC. All right. If you like, hit the pause button and say why might or might not that be true. Okay. If you're back, the answer is that's not a proper conclusion. Okay. And the reason why, if you recall, the data for nominate scores, it's just the first column, it's legislator 1, legislator 2, legislator 3, 4, and then second column will be the roll call votes on roll call vote 1. Third column's votes on roll call vote 2. And this will just be zeros and ones to indicate whether they voted yay or nay. And so on, okay? That's what the data is going to look like, and that's the data. That's all the data Poole and Rosenthal used to estimate these ideal points. Now, here's what happens. When you have the data, they only do one house at a time, and also they only do one Congress at a time. Now, one Congress, I mean the time period. So a Congress is a 2-year period. So, it comes from the House members have a 2-year term length. So the first Congress started in 1789 and ended in 1791. And the second Congress started in 1791, ended in 1793, and so on. Okay. So to input the data, at least for the original vanilla nominate scores, what Poole and Rosenthal would do is they would first get all the roll call votes for, say, the House for a particular Congress, say the 112th Congress, and I can't remember the years with that. I think it's sometime in the 90s. Say it's 1999. The Congress that started after the 1998 elections began in 1999. Probably ended in December of 2000. Say that's the 212th Congress or whatever the number is. But the key is the data would only have those 435 members in the House serving for those 2 years. It would not have any data from the Senate, nor would it have any data from other Congresses, other time periods. Okay, so the key is for this question here, Chuck Schumer versus AOC, the Chuck Schumer score is estimated only from the Senate data. That would be a completely different data set. And the AOC score was estimated only from the House data. It's only from the House score. And there's nothing in the data to link up those two scores. It could be, it's kind of like comparing Fahrenheit with Celsius. It's two different scales because it's the cut points are they have two different sets of cut points in the two different data sets, and the reason they have two different sets of cut points in the data sets is because they have two different sets of roll call votes. Okay, so you can't make that conclusion. It's not proper to make interchamber comparisons, nor is it proper to make intertemporal comparisons. That is to compare House members from two different Congresses. Okay, so that's important to know about the nominate scores. Okay, now that's the vanilla version of nominate scores. So later on, here's what Poole and Rosenthal do. They do make some versions where you can make inter-chamber comparisons or intertemporal comparisons. By intertemporal, I mean across Congresses. So yeah, you could say, within the 212th Congress, yeah, they lump the 2 years of that all in one data set. So you compare across those 2 years, but you can't compare against other years. Okay, so that's what I mean when I say you can't make intertemporal comparisons. Okay, now let me explain what the different versions are. Okay, now I think this is the first new version that they made. Call it denominate scores. Okay, the D stands for dynamic, and so I was going to say Poole and Rosenthal, right? Actually, I think it's only Poole. I think I got this from Poole's website. So it's on VoteView. VoteView.uh. You know what? He changed this. I downloaded it when Keith Poole was at University of Houston. So as I talk now, he's at University of Georgia, and it may be moving. I think Jeff Lewis at UCLA may be doing something. So be sure to just Google VoteView. So denominate, it says, because of the overlapping generations nature of the estimation, scores in one Congress are directly comparable with scores in another Congress. So I said, so if you had one Congress, your data set with just one Congress, say the 212th House, and then you had another data set with the 213th House, those are two different data sets. Vanilla nominate does not say anything about can you compare the two scores. So, if some House member score went up from 0.3 to 0.35, it's not proper to say he became more conservative. Okay. With denominate, though, you can make such comparisons. And I said, now, how can you do this? Because the roll call votes are different in the two different data sets, and therefore the bill locations are different in the two different data sets. Therefore, the scales are different. Well, what they do, there's a little more to it than this, and I'm going to explain in the next session. But here's the simplest way you could link up the two data sets. So the two different Congresses, that is the two different time periods for, say, one House, is you just assume that every member who serves in both Congresses, so anyone who continues from the first Congress to the second, maintains his same ideal point. So you only estimate, so if there's one person who serves in the 212th and 213th, instead of estimating two ideal points, you just say, let's assume it's the same and estimate one. Okay. So by doing that, by assuming that all the members of Congress who overlap have the exact same ideal point, this allows you to make comparisons of bill locations from two different Congresses, because you've got the votes of people who have served in the two different Congresses, and then once those bill locations are comparable, then you can actually then your estimates of ideal points for the other congressmen, the ones who don't serve in both Congress, will be comparable with each other. Okay, so that's what's going on with denominate. Okay, W nominate. So all that is, let's see if you can see right here. Okay, when we talked about the utility function for each legislator, and it was e to the omega squared times d squared. Okay, omega squared was a scalar in the vanilla nominate. In the new nominate, what they call W nominate, they say, well, when we start looking at multiple dimensions, now so far I've stuck with this one dimension. If you in the vanilla nominate, if they looked at two dimensions, that W is still a scalar. Okay, or that omega is still a scalar. However, in the new version, the W nominate, what they estimated was two different omegas. You could estimate an omega 1 let's call it W1. I think Poole started calling it W. Call it W1 for dimension 1 and W2 for dimension 2. So what this does is essentially this. Um, when we're in the two-dimensional world and say person I's ideal point is here, we said his or her utility for voting for a particular bill or amendment or whatever is a function of the distance. Okay, so what that means is the indifference curve has got to be a circle. So all bill locations that are the same distance from xi must give him the same utility. Okay. What W nominate does is it says, well, if we put a different weight on the distance in the first dimension versus the distance in the second dimension, what that does is it forces these indifference curves to be an ellipse. So it looks something like this. I think that's, I never remember. I think that's where the W2 is bigger, I think. I can't remember exactly. You don't need to know that, but the key is that the W's are different. That makes the indifference curves ellipses rather than circles. From that, you can actually estimate different versions of different omegas for the different dimensions. And so what that does, it gives different weights to the distances in different dimensions. Okay. Okay, so that's W nominate. All right. Okay. Let me go to 4. DW nominate. Okay. All that does both. Okay. So it does that assumption. Assume you have the same. If you serve in 2 different Congresses, then you have the same ideal point in the 2 different Congresses. And then you add on the W nominate aspect of it. The 2 dimensions have different weights. Okay, so that's all that DW nominate does, is it combines the 2. Okay, now so far, everything I've done does not allow interchamber comparisons. Okay, so with vanilla nominate, W nominate, D nominate, DW nominate, the data set for the Senate is completely different from the data set from the House. Okay, so for that reason, the same thing when we say AOC has a score of, what did I say, negative 0.6, Chuck Schumer has a negative 0.8. You can't say who is more liberal or conservative because you don't know what the cut point. You don't know how the cut points actually measure up. You may have arbitrarily set them in between 0 and 1, but really it's possible that compared to the House bill locations, the Senate bill locations were all above 1 even. So you don't know that unless you have, if the 2 data sets are completely separate. Okay. Now, given that, Keith Poole said, well, there's an easy way to redo nominate scores so that we can make comparisons across the 2 chambers, and he calls this common space coordinates. And all he does there is, it's like the denominate case. I said you look for the legislators who served in the 2 Congresses, who continued, and you assume they have the same ideal point in the 2 different Congresses. Well, Poole said, well, we can do something similar from House to Senate, because there are occasionally people who start off in the House and move to the Senate. Actually, there's one case in history, his name's Claude Pepper, where a guy was in the Senate and he went back to the House. So there's some cases where people move from chamber to chamber. There's not that many. So in a typical year, you look at all the senators, and something like only a quarter. But, it's not nothing. Have served in the House at some point. So what you could do is just put all your data sets together You have to combine years to do this too, by the way, because you almost never have a case where a person goes from the House to the Senate during the same Congress, unless there's like a death in the Senate or something. That can't happen. Um, so you have to have your data set. It's got to be more than one Congress. So it's got to be several years. Plus, you combine all the data from House and the Senate. And then you assume all the members who served in both chambers maintain the same ideal point. Okay, once you do that, that links up the chambers. And then it is possible to make comparisons across the chambers. It is proper to make interchamber comparisons. And let's see, Poole wrote the common space scores place the members of the House and Senate in the same space. This allows members to be compared across chambers and across Congresses. The scores are derived from the W nominate scores utilizing a scaling technique explained and blah, blah, blah. Each legislator is assigned a single coordinate throughout his or her career so that members who served in both chambers will have the same coordinate in both. Okay, so that is common space scores. Okay, so I've given you a brief explanation of the different versions. You have the handout. You can also go to VoteView website to learn about this. Now, I said that denominate, so it links the scores across Congresses or across time. And I said it's like they're making each legislator maintain the same score from Congress to Congress. Now, that's not quite true. It's a little more, they've really relaxed that assumption. The assumption that they actually use is not quite as restrictive as I've just said. So let me explain that assumption. So that will be the next part, 6.4. I will explain exactly what goes into computing denominate. Okay, and so I'll see you there.